Okay, well, let's observe something now. If x equals -3, what's this polynomial equal to? Well, if you put in -3, you get 0 here, right? Meaning the whole thing is 0. You look at the factored form to see where the zeros are, okay? You don't look at this. You could plug -3 in and you would get 0 if you use this expression, but this expression makes it obvious that the result is 0, right? Okay, well, that's x minus -3 then, isn't it? Okay? So now I'm saying if x minus z divides a polynomial p of x without remainder, then x equals z is a 0. Of that polynomial. Okay? Why? Because the quotient's going to be a polynomial. So we've got to call it something. Since it's a quotient, we'll call it q of x. Okay? Then your p of x is going to be x minus z times q of x, right? Now let me kind of write that out. We have our x minus z into, and that's a square root sign. That's not what I need, is it? I don't really want parentheses around that x minus z. So let's fix that. Okay? X minus z divided into p of x gives us q of x, no remainder. So x minus z multiplied by q of x equals p of x, right? So that p of z equals x minus z times q of z. Now q of z could be anything at all, but x minus z, I'm sorry, it's not x minus z, now it's p of z, it's z minus z equals 0 times q of z. Which equals 0. I want you to ponder that, but at least understand that if x minus something divides the polynomial, then that something is a 0 of the polynomial.